Now that we have looked at the library of functions, we're going to move those functions around. We're going to alter them a little bit and determine how that looks graphically and how it looks algebraically. There are three main types of transformations that we're going to look at. Vertical transformations, things that change or move the graph in some way vertically. Horizontal, so it may move the graph horizontally or change it in some way. And then other. There are some other random things that we'll talk about towards the end here. Vertical transformations, and really within each of these categories of vertical and horizontal, there are a couple main subcategories we'll talk about. There are things called vertical shifts and horizontal shifts. Okay, so if you take a graph, you can move it around horizontally, you can move it around vertically. There are also stretches and compressions. We'll do those first. And same in the horizontal side. Okay, so basically you could take a graph and you can either compress it vertically or stretch it out vertically, or horizontally. You can compress it down or stretch it out. Okay, so you have all of those options. And then the other category is reflection. Okay, so you can reflect graphs. Either vertically or horizontally. So you could take a graph like a parabola that opens up and reflect it so that it opens down. You could take a graph like like your reciprocal function, for instance. Your reciprocal 1 over x function looks like this. You could reflect it across the y-axis. So sort of spin it across the y-axis, you would get a graph, in the second and fourth quadrants. That would be a horizontal reflection. Ironically, that one also is a vertical reflection. But you get the point. You can reflect things or rotate things around an axis or reflect it through an axis. Same idea. Either horizontally or vertically. And so when we talk about these reflections, a vertical reflection is really, it's really a reflection across the x-axis. And when we talk about a horizontal reflection, that's really a reflection across the y-axis. Okay, so those are the main categories of transformations. Now, under the other category, you can do things like take the absolute value of a function, for instance. That's the main one we're going to see. Taking the absolute value of a function basically takes any part of the function that's in the negative side, like under the x-axis, and reflects it up above the x-axis. And so you end up having the entire function contained above the x-axis when you do an absolute value. Okay, so those are sort of the main transformations that we're going to do. Now, these move graphs around, change the shape slightly of a graph, and so we'll explore those, all of these items, and I think we'll start off looking at a function like the function f of x equals the square root of x. Okay, I'm just going to give you a quick overview of each of these different transformations and how you perform them on a function algebraically, and then kind of what they look like graphically. Now, vertical transformations occur basically by doing something on the outside. I call it on the outside of a function. Okay, so you're going to take a function's output And to change something vertically, let's say you wanted to shift the graph vertically. Well, then you would take the function's output and you would add something or subtract something from every output. And that moves every point on the graph the same amount vertically, either up or down. Okay, so if I added, let's say I added a 7 to that function, okay, on the outside of the function. So you're not doing anything inside by the x, you're doing something on the outside. Then what you're doing is you're taking the output of the original function and adding 7 to every output. So that moves every point up 7 units and essentially shifts the entire graph 7 units high. If I were to subtract 7 instead of add 7, well, then you just lower the graph 7 units. Okay. So again, vertical transformations occur outside of the graph. They're done after the output from the original graph. We can also, instead of shifting is done by adding and subtracting. Maybe I'll write that in here. Shifts are done by add or subtract. Okay. Stretches are done by multiplying or dividing. Okay. Well, we're going to call it multiplying either way. I guess we could do it either way. So stretches are done by multiplying. So you take a graph, if you multiply the output by, let's say, 2, then you're doubling its distance from the x-axis, you're doubling its value, and so you're stretching it away. Now something that starts farther away is going to stretch more than something that starts closer, because when you multiply by something, when you multiply by a constant amount, a smaller number isn't going to grow as much as a bigger number is. Okay, so things get pulled away from the x-axis. Compressions occur when you divide, or what I would actually call multiplying by a number less than 1. Say you cut it in half, okay, multiplied by 1/2, multiplied by 2/3. Then what you're doing is you're going to be taking the distance between the x-axis and a point on the graph, and you're going to be cutting it down or bringing it closer to the x-axis by that factor, and that's going to result in a compression of the graph. It kind of makes it shorter. Okay, so that's done mainly by multiplying. But again, compression or stretches are done using. I'll use this asterisk. We'll use an asterisk for multiplication. So again, stretches are done by multiplying by something greater than 1, compressions by something less than 1, or between 0 and 1. Reflections are done by taking the negative. So if I wanted to reflect the graph of square root of x vertically, I would have to multiply that function by a negative. Okay, so that's going to take everything from above the graph and make it below, or I'm sorry, everything from above the x-axis and make it below, and everything from below goes to above the x-axis, so it reflects everything vertically. Okay, so that's done by multiplying by a negative. Okay. So all of these things must be done on the outside of the function again. Okay. They're done on the outside of the function algebraically. So it'd be like adding the 7 or multiplying by 2 on the outside. So 2 times the square root of x would do a stretch of the graph. With horizontal transformations, those are actually done algebraically on the inside. They're done to the x value. Okay, so on the inside of the graph. The operations are the same, and so shifts are done by adding and subtracting. Okay. However, what's weird about the horizontal shifts, and we'll get to this as I go through and actually plot the graphs, is that horizontal shifts are opposite sign. So if I were to add something inside the root here, like the square root of the quantity x plus 2, that would actually shift the graph left, and the subtraction shifts the graph right. So it's actually the opposite. We'll discuss that a little bit more in the next video as we go through some of the details there. Okay, so but again, shifting is done by adding and subtracting. Stretches and compressions, again, are done by multiplying. And you can compress a graph horizontally or stretch a graph horizontally. Either way, again, depending upon whether you're multiplying by a number greater than 1 or between 0 and 1. Finally, reflections are again multiplying by a negative number. And so if I were to take and multiply this x on the inside by a negative, like I take the square root of a negative 5x, that negative 5 produces a reflection horizontally. The 5 would also create a either a stretch or a compression. We'll talk about that later. Okay. Okay, so that gets us into kind of a summary of where we're going with this. And then, of course, if you were to apply an absolute value, you just throw the absolute value around that entire function, and then that will, again, it basically reflects any negative portion of the graph into a positive portion and makes all of the graph above the x-axis. Okay. So again, we'll go through a specific example here in the next video. I just wanted to give you kind of an overview of where we're going and give you a summary so you can kind of see, categorize everything all in one shot.